As we take a look here at section 5.6, fitting a line to data, essentially what we're going to do in this section is just create a scatter plot, and then we're going to write equations to model the data that we've created. Okay, and so some vocab that we need to become familiar with first. What exactly is a scatter plot? Very simply, it's a graph that's used to determine whether there is a relationship between paired data. Okay, in other words, over on the right hand side here, that's a scatter plot. It's just a bunch of random points that are plotted on a graph. A line of best fit is a model that's used to represent the trend in data, showing a positive or negative correlation. And what correlation is it's the relationship between two data sets. In other words, we're going to look at this scatter plot and it's going to tell us exactly what type of correlation we have, if any. Okay, so positive correlation is when your Y tends to increase as X increases. Okay, in other words, your independent and dependent variables increase at the same rate or relatively the same rate. And so the scatter plot of positive correlation might look something like this. Okay, where they're all kind of going up in this direction. And the easy way to remember that is if you were to draw a line through those points, the slope of that line is positive, therefore it's positive correlation. Okay, negative correlation is probably exactly what you think it is. Okay, it's when your as your X increases, your Y tends to decrease. Okay, so something like that. Again, if I were to just sketch a quick line going in the general direction of those points, then clearly the slope of that line would be a negative slope. And then if there's no apparent relationship between the data, then there's no correlation. So in other words, if you just have some random points over here that are kind of just scattered all over the place, and there's clearly there's no consistent relationship, then you would say that there's no correlation or relatively no correlation. So example 1 here says describe the correlation of data graphed in the scatter plot. And so all we're trying to identify is what type of correlation do we have. So when I look at part A, I can easily draw a line going through those points pretty closely. Therefore, and the slope of that line is negative. Therefore, this graph has a negative correlation. Part B, I would argue that has a positive correlation. Of course, you have a couple outliers here that are kind of far away from that line, but for the most part, most of your points go in that general direction, and therefore the correlation here we would call positive. Part C, I would still consider that to be relatively positive correlation. They're all kind of going up in that general direction, so I would call that positive correlation. And then part D, this one, again, I would argue, at least to me, it looks like a lot of your points are kind of going in this general direction, and so I would consider them to have negative correlation. That's one where it's kind of, you could, I guess, argue that there appears to be no correlation, but really when you look at the general trend, as X gets bigger, your Y is clearly getting smaller. So I would argue that's negative correlation. Okay, example 2 says draw a line of fit for the scatter plot. Write an equation for the line in the form indicated. So when you draw a line of fit, what you're going to do is you're going to choose 2 points that lie in your scatter plot that you feel best represent the data. Okay, and so in other words, I'm going to choose this first point here, and to me, I think if I choose the last point, that's also going to be a pretty good representation. You're going to want to choose 2 points that you can identify and that you know what they are. Okay, and so when I draw a line through these 2 points, okay, I think we all agree that that's pretty close to representing that data. And really what you want to look for is you want to have preferably an equal number of points above and below your line. Okay, so I would say that these 2 points, the blue points, are clearly below the line. I would argue that the 2 that I'm highlighting right now in green are pretty darn close to lying on the line. And then obviously the ones I'm going to highlight here in black that I'm kind of shading around are above the line. So I think that's a pretty good representation of our data. And again, if you were to choose 2 other points, it wouldn't be wrong. Your equation would just be different. Okay, and so again, I'm using the 2 red points. The red points here to me appear to be 1, 7, and the second point appears to be 8, 2. And it says write it in slope-intercept form. Okay, so I can do this. I have 2 points. I can find the slope. The slope is y2 minus y1 over x2 minus x1. 7 minus 2 is 5. 1 minus 8 is negative 7. There's my slope. Okay, and now I've got to find my y-intercept. So I have y equals negative 5 over 7x plus b. All right, I'm going to go ahead and use this first point. Okay, so I have 7 equals negative 5/7 times 1 plus b. Add 5/7 to both sides. And when I do that, I add 5/7 to both sides, I get my y-intercept to be 7 and 5 over 7. I'm just going to leave it as a mixed number. So your final equation here is y equals mx plus b. Okay, and so if you look at your graph, the y-intercept should be almost 8, and that's pretty darn close to 8 there. So I think that's a pretty accurate representation of our data. That would be the line of fit. Okay, part B, same idea. Pick 2 points that you feel best represent your data. And so the 2 points I'm going to choose this point, and I'm going to choose this point. Okay, and so when I draw the line that goes through them, that's about what it looks like. I think that's pretty close. 2 above it, 2 below it, a couple that are pretty darn close to line on it, so I think that's pretty good. So the first point there is -2, -1. The second point is the point 1, 2. And now we're right back to square one, point slope form. Okay, so I need slope. So y2 minus y1 over x2 minus x1 plus 2 plus 1 is 3. 1 plus 2 is 3. The slope here is 1. And so my equation could be one of two things. Remember, point slope form, that's y minus y1 equals m times x minus x1. Plus, 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 plus. So y plus 1 equals 1 times parentheses x plus 2 is 1. Or you could also write y minus 2 equals 1 times x minus 1. Both of those equations represent the same line. So there's your introduction to this idea of line of fit. Part C, we'll do one more of these together. Again, pick 2 points that appear to represent your data. And so for this one, I'm going to choose this point up here. And actually, I'm gonna take that back. I don't like that point up there. I don't think that represents the data. It's going to represent the data very accurately. So I'm going to choose, I'm going to go here and here. Okay, this one was a little bit more difficult because your points are more spaced out. All right, and again, it doesn't matter what 2 points you choose, just whatever 2 points you choose, those are the points you're using. So the first point, -3, 1, and the second point is 1, -2. Okay, and so I find the slope first. So when I find the slope, 1 minus -2, change in y over the change in x, plus plus, that's 3 over -4 is my slope. So I get y equals -3/4 times -3 plus b. I'm solving for my y-intercept now. So 1 equals 9 over 4 plus b. Subtract 9 over 4 from both sides. The number 1 is actually 4 over 4. So I have 4 over 4 minus 9 over 4. So your y-intercept is -5/4, okay, or -1.25, whatever you want. And so now what you have for your equation, you have y equals -3/4 x minus 5 over 4, but they want it in standard form, so I'm going to add 3/4 x to both sides. And so in standard form, you have 3 over 4x plus y equals -5 over 4. And there would be the equation of your line of fit for this particular data set. Okay, we'll do example 3 here together. So this one's no different than what we've been doing, except we're going to create the scatter plot. Okay, so -2, 2, -1, 1, 0, I'm sorry, -1, 0, nothing at 0. At 1, we have -2. And at 2, we have -3. So there's my data. I'm going to go ahead and just use the first point here. And I'm going to go ahead and use the last point. The first point and the last point. So there's my data set. Okay, so again, the 2 points I'm using, -2, 2, 2, -3. It doesn't indicate what equation, so I'm going to do y equals mx plus b. Okay, so slope, change in y over the change in x. So plus plus, that's 5 over negative 4. So now I plug in for x and y, so 2 equals negative 5/4 times negative 2 plus b. I'm just going to cancel some things out here to make my life a little bit easier. So over here, this is really positive 5 over 2. So I'm going to subtract 5 over 2 from both sides. 5 over 2 is the same thing as 2.5. So 2 minus 2.5 is negative 0.5 or negative 1/2. And so now my equation is very simply y equals negative 5 over 4x minus 1/2. And there's your line of fit for this particular scatter plot. That one's the same way, so I'm going to let you guys do that. And to be honest with you, this one's also the same, so I'm not going to just reinvent the wheel here and keep doing the same types of problems. Make a scatter plot, draw a line through any 2 points that you believe represents the data, okay, and then simply write the equation of that particular line. So if there are any issues here, obviously you'll have some time in class to work through some problems together and resolve any issues.